Optimization in Manufacturing by Elijah, Nathan, Marvin, and myself. For our introduction, our team chose to analyze the efficiency of manufacturing facilities, not any one in particular, but we looked at 3 similar studies and we used those to determine what our inputs and outputs should be. Specifically, 3 inputs and 3 outputs. And then to make sure that the information when we were finding a solution stays accurate, we decided to have 18 different DMUs. The 4 outputs for us were wages for the workers, the revenue of the facility when selling the product, and then the number of products that the facility produced. For our inputs, we had the number of employees per DMU, the size of the facility or the room, and then the materials, the raw materials that were available in pounds.
So moving on to the methods, as you can see on the graph, it is recommended to increase the number of employees in DMUs 2, 7, 9, 15, and 18. That is because the revenue increases substantially while also minimizing wages and maximizing revenue. Now, jumping over to the other chart, you can see that it is recommended to decrease the number of employees, but in return, the amount of money paid into wages increases. We can see this in DMU 2 as well as 15, where the numbers of employees decreased, but more was paid in wages.
Moving on to stage 1 of our analysis. This stage is primarily just to focus on the overall efficiency of each of the DMUs. And then when looking at this chart, it's easy to see that surprisingly, most of the different DMUs were considered to already be efficient, with their lambda values equaling 1 in the same DMU column and lambda column. Although there were some inefficiencies, specifically DMU 15 was the closest to being efficient, but still inefficient. And then there was DMU 18 that was considered inefficient, DMU 7, and DMU number 2.
So moving on to the second part of the analysis, this is a more in-depth look as to how profitable as well as efficient each DMU is performing. So as we can see in the first analysis, DMU 16 is showing that it's performing at an efficient rate. But when the second analysis is done, it's shown that it is not as efficient as we think. With DMU 7, as well as 15 and 18, if you break up the values into more lambda values, it is finding what the most efficient process would be. So you can see this in DMU 18 here, where the values are split up more, as if you were to look at the first analysis, the values are more diverse and disperse.
Now moving on to the slacks in stage 2, it uncovered hidden inefficiencies in each of the corresponding DMUs and displayed them in the correct input and output that could be changed. Excel was able to calculate a slack value for each DMU code except for DMU code 2, which Excel could not find a feasible solution. That just means that nothing that was anything that Excel could generate, it would not cooperate, and it was just non-efficient.
So that concludes the information from our particular model. The poster presents a result that the DEA is to find inefficiencies within the facility. The facility produces 4 products, and the study used 18 different input and output variables to measure efficiency. The results of the study show that the facility is operating at a relatively low level of efficiency. The most efficient DMU is 15, which had a lambda value of 0.9. This means that DMU 15 is producing 90% of its potential output with the given inputs. The study also identifies the slacks for both, each DMU. Slacks are measures of inefficiency, and a higher slack value indicates a higher level of inefficiency. The two DMUs with the highest slack values are DMU 2 as well as DMU 18. This means that these two DMUs have the most potential to improve their efficiency. The study concludes that the DEA analysis has identified hidden inefficiencies in the manufacturing facility. The study also recommends that the facility should focus on improving the efficiency of DMU 2 as well as DMU 18. This concludes our poster presentation. Here are 3 articles related to the information that we gathered online. Feel free to type these in and use them at your disposal. And thank you very much for listening.